Hello all. In this session, we're going to understand how to fit polynomials with Numpy. Now for this, let us understand the steps that are actually involved in identifying the polynomials, fitting the polynomials using the Numpy. Now, we actually first of all, we just need to start with the data preparation. What is data preparation? Initially, what I'm going to take is, I'm going to take two arrays. Array of X, array of Y. What is X? X is of independent variables. Y is a dependent variable. Now, when you look at it, relationship in between the variables that are in X, the variables that are in Y, there is a relationship in between Y and X. Y actually is X square plus X. 1 square plus 1 is equal to 2, 2 square plus 2 is equal to 6, 3 square plus 3 is equal to 12, 4 square plus 4 is equal to 20, and 5 square plus 5 is equal to 30. So this is the output data. This is called the independent variable. Now X is the independent variable, sorry, Y is the dependent variable. Now, as I already told you, X is the independent variable, Y is a dependent variable. Now, how to start with the polynomial fitting in NumPy? To fit a polynomial to the data, first of all, you just need to understand we need to use np.polyfit function. This polyfit function finds out the quotients of the polynomial that best fits the data. It is going to identify the quotients of the polynomial. So how you will be able to use it? As I already told you, the independent variable data, Y is the dependent variable data. Now the degree. What degree that we are going to use? Here we are going to use 2 for the quadratic polynomial, 3 for cubic polynomial. But here, since it's a quadratic polynomial, we just are going to use only 2. Now, what is the line of code that we need to write? Here, what I need to do is I need to call np.polyfit. This polyfit function is going to get the quotients of quadratic polynomial, and it just is going to transfer the quotients into the quotients identifier. Now the quotients identifier is going to include all the quotients of the polynomial. As I told you, this function returns the array of the quotients that represent the polynomial. Now, see, what is A here? A is quotient of x square. B is the quotient of x to the power 1. And C is the constant term. Okay, now the return quotients are, let us say, ABC is equal to 1, 1, 0. It means the fitted polynomial is obviously x square plus x is equal to 0. It just returns what? It returns the polynomials. Okay, the quotients. For instance, bigger pardon, this is the quotients. And right then, f of x will be equal to x square plus x is equal to 0. Now, how would you be able to create the polynomial function by the generated quotients? For that, what you need to use? You just need to use np.poly1d. This poly1d is going to create a function out of the quotients that you actually have been have generated out of this, the x and y. Right then, you just need to use poly1d function. The parameter should be the quotient that's been generated. This polynomial Python function that you used to evaluate the fitted polynomial at any value of x. For an example, polynomial 3 would compute the y value for x is equal to 3. Okay, again, if you say polynomial 2 would compute the y value for x is equal to 2. If the polynomial is equal to 1, would compute the y value for x is equal to 1 for the fitted polynomial. Now, how to evaluate a polynomial. Now we just need to say, we need to take the polynomial. Already we know the polynomial function. Polynomial function have actually been defined by using the quotients, by using the poly1d and the parameters quotient. Right, then what we need to do is, we just need to pass the x value, whatever the x value that you want to find out a polynomial, then that x value should be taken as a parameter. You should be passing into the polynomial function. Then this polynomial function is going to generate the y value, corresponding y value of the fitted x into the polynomial. This is how you will be able to fit the polynomials into the NumPy. But for the visualization, you need to use the matplotlib. Since the matplotlib is not covered, I just want you people to use this code for what do you call visualizing the polynomials. So this is the polynomial, how you're going to fit using the Numpy. Let me walk through the total code again. For this, we just need to import NP, and we also need to import matplotlib for visualization. Initially, we just have taken X and Y, where X is an independent array, Y is a dependent array. Right then, I'm going to take the coefficients for NP polyfit, where X and Y, we just are going to take for quadratic polynomial. Right then, we just are going to create a polynomial function for which we just are going to use poly1d. To the poly1d, we should be able to pass the coefficient that's been generated out of this. Right then, what you need to what you can do, you just can directly pass whatever the value that you want to find out for the y fit. Okay, to the polynomial function, if you pass whatever the value of x, then a result will be passed to the y fit. And if you ever want to visualize this data, I just want to be able to see this, go through this code. Okay. For that, you need to use matplotlib. Thank you so much.